Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video we discussed about file handling and many operations, pointers and programs. So we have done with the file handling. Well, in today's video we will start with a new topic which is dynamic memory allocation. So we will discuss about the difference between static allocation and dynamic allocation. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Dynamic memory allocation. The name itself tells you it is the memory allocation that is done dynamically, that what we say as during runtime, during execution time. So let us have the difference between static memory allocation and dynamic memory allocation. So in today's video, we'll just have an introduction to dynamic memory allocation. There are many things to discuss with dynamic memory allocation, and there are many concepts that what we need to learn with dynamic memory allocation. We will deal with all those things in separate videos. So let's have the difference between static memory allocation and dynamic memory allocation. Static memory allocation. It says it is the allocation that what we do during compile time. So we call this as compile time allocation. But actual saying, during the process of compilation, we all know how the compilation takes place. If you have any doubts regarding compilation, you can just check out the playlist. In the playlist, you can find how to compile the program, that is the compilation process. So we know that the source code will be given to the compiler and the compiler will translate your source code, and expanded code is generated and we are going to get an object code. An object code is generated. So this object code consists of the machine level instructions, and after getting the object code, we are going to link many subprograms. We are going to load to the memory, then only the memory will be allocated. But during compile time itself, the memory will be fixed. Say we will have some variable declarations like int a comma b, and we all know how many bytes has to be allocated for a and b with respect to the data type. With respect to integer data type, if it is 16-bit machine, or what we can say, it depends upon the machine that what we use, it may take 2 bytes or 4 bytes. So that amount of memory that what we need to allocate, it is fixed. So we say it is compile time allocation. Obviously, when the program gets loaded to the memory, to the main memory, then only the allocation will be done. But the amount of memory to be allocated is fixed. So we say it is compile time allocation. Whereas dynamic memory allocation is runtime allocation. That is, during execution time itself, we allocate the memory. We are going to decide. So the amount of memory to be allocated is not fixed during compile time. Whereas in static, the amount of memory to be allocated is fixed during compile time. The static memory allocation, the static means what the name static says, it is fixed. Whereas dynamic, the amount of memory to be allocated is not fixed. It is going to be decided during runtime itself. How much amount of memory we need to allocate, it is decided during runtime, and for that we make use of many other concepts like pointers. So we make use of pointers to deal with the memory allocation. So it is runtime allocation, or also call it as execution time. So this is what dynamic memory allocation. Now, memory is fixed and it cannot be resized. So once the amount of memory that what we are going to provide to the program, it is fixed. So for example, I say I have an integer array a of 100. So this is fixed. So 100 means I say maximum 100 elements I can store. So that much amount of memory is fixed. And we cannot change that. We cannot resize it. Whereas in the dynamic memory allocation, memory is not fixed. It cannot be fixed during runtime. We are going to decide during runtime that how much amount of memory we require. So I can resize the memory. How much ever memory I require, I can allocate only that much amount of memory. But here when I say in static, I say 100 means maximum 100 elements I can store. So A of 100 means 100 elements I can store. So with respect to integer, one integer value 2 bytes, so 200 bytes will be fixed. I cannot resize that. So here, memory to be allocated should be pre-known to the user. So we have to provide some approx size so that we should decide how much amount of memory we require. So it should be pre-known to the user. But here, memory to be allocated is not known. So during runtime, during execution time, we decide how much amount of memory we require. Let me give you a small example. Say I know I have 10 students to enroll in my class. So I know the actual amount of data that what I require. But I don't know how many students are going to enroll to my class. Then it is dynamic. So I cannot decide the amount of memory. So the amount of memory is not pre-known. Here, once I allocate the memory, say 100, I say 100, but I don't store 100. I may store 5 or 10 values. The remaining memory will be wasted. So we have seen the disadvantage of arrays, right? See, I always mention the maximum size, but I can use less than that, but not more than that. So memory is wasted, so it is not used effectively. But here in dynamic memory allocation, memory is not wasted. We only allocate the memory which is required. So the memory is used effectively. The next point. It uses stack memory. Talking about the memory, for the program, we have different sections of memory allocation. Say for some code that what we write, some memory is allocated. So we have different frames of memory. And for other global variables, local variables, static variables, we have some memory frame. Then we have stack memory. Then we have heap memory. So for the static memory allocation, we take the stack frame of memory. Whereas for the dynamic memory allocation, we take the heap frame of memory because heap memory is very huge. So I can decide the memory amount of memory allocation during runtime and I can get that memory from the heap memory. And how do we get that? How do we allocate the memory? So here, with respect to dynamic memory allocation, we have to deal with still many topics, like we have to deal with how to allocate the memory. So there are many functions like calloc function, malloc function. Then we also have the function called as free function to deallocate the memory. So once the memory is allocated through calloc and malloc, we have to deallocate the memory. But here we need not free the memory. When the program becomes to the end, or when the program reach to the end of the code, then the memory is released. So till the program is active, the memory will be active. So when the program ends, the memory will be deallocated. So we need not have any extra function to release the memory. If the program is active, then the memory will be active. When the program is not active, then the memory will not be active. But here we have to deallocate the memory using free. Then we also use pointers here. So pointers is very much required here because to deal with the memory. So here during runtime we allocate the memory randomly, means the randomly allocated memory can be managed only by pointers. So we make use of pointers. So well, I have separate video for pointers. I have done that. Please do check out the playlist. You have many videos of pointers. So we have to make use of pointers here. We have to make use of many functions to allocate the memory, and to manage, to handle these memories, we have to use pointers. So this is what the introduction to dynamic memory allocation. So hope you have understood with this. So we will have separate videos for all these content. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.